Hi everybody, it's me, Miss Aninga. I thought I would take some time out to show you a little bit of practice from this guy, which it's backwards right now, but this is the bonding practice that I posted online this morning. So I wanted to do some examples on there with you so that you can see how we go through bonding as a review for you. So I'm gonna go over both ionic and covalent bonding with examples from our practice. Okay, so I'm going to switch you guys over to my camera over here so that we can do some of these together on paper. Okay, alrighty, so let me roll up my sleeves here and then we can get started. So I'm going to pull some of those over. First off, you'll see that this assignment here is broken up into different parts. It's broken up into 4 parts with a challenge part on the back. So what I'm going to do is I'm going to do a couple of these with you. I'm not going to do part 1 because part 1 is just definitions that you can look either on your notes or online at, and just whatever you find, make sure you put in your own words so that you understand it easier. Okay. Part 2, this is similar to one of the assignments we did before, where you're just predicting whether your bond here between these elements is going to be a ionic or covalent bond. And so it kind of takes you through by looking at if your first element is a metal or non-metal, same thing with your second. And then you gotta determine what it is. And, defining them up here kind of helps. So if you don't know the difference between ionic bonds and covalent bonds, your definitions that you look up can help you. But I will tell you right now, ionic bonds are between a metal and a non-metal, whereas covalent is between one or more non-metals. Okay? So if we look down here at these real quick, let's do a couple of these. Let's do our first one. So our first element, Na sodium, if we look it up on our periodic table, see that sodium is over here. It says it's an alkali metal, so that is a metal. Now we look at element 2, which is F for fluorine. Look on here and we see that fluorine is over here. It's a non-metal, so that's what we put. It's a non-metal. And like I said before, between these 2 bonds, ionic is the one between a metal and a non-metal, whereas covalent is between 2 or more non-metals. You got a metal, you got a non-metal. This is an ionic bond. If you want to put ionic or just I, that's great. Let's do another one here. C and I. C, we look on here, stands for carbon. Carbon is a non-metal. And iodine, or iodine, is also a non-metal. And since it's not a metal and a non-metal like the above, it's a non and a non, which means it is a covalent bond. Okay? Then there's 3 other ones. Try and do those ones on your own because those ones can help you predict bonds. Pretty easy, really. Next, we're going to look at part 3. Part 3 talks about writing balanced ionic formulas. So all of these that you're going to be dealing with are ionic bonds. Your directions say up here, use your periodic table to fill in the table information and then use that information to make a balanced ionic compound. And then beware of polyatomic ions. I gave you a list of them, or a link to a list of them here. I have my own, which I've colored, which I will use during this whole thing. I've filled in these two for you already, but I'll do a couple more to show you how we can do these. This guy right here is a hint for how you can make the correct looking formulas on Google Docs, and that I can show you as well if you want later, so that you know the trick behind that. All right. So with here, we're looking at ionic bonding. Ionic bonding is all about charge. Okay? It's all about charges. And when we take our ionic bonds, if you remember, ionic bonding works so that we get a total charge. When we put our two things together, it should equal 0. So charge of E1, or element 1, plus the charge of element 2 should equal 0. Okay? And you can kind of see that up here with number 1, where we have sodium and iodine. If we look at the charges, that's connected with valence electrons. If we look here on our periodic table, we can see sodium has a charge of +1. Its valence electrons is 1. The reason that it's +1 is because it's easier to give away this 1 electron than to gain 7 more. So sodium loses it to get a +1 charge. Okay. So in order for sodium to be happy, it wants to give that 1 away. So that's why we have sodium gives away 1. Whereas if we look at iodine, all the way over here, iodine we can see has 7 valence electrons, and so it's easiest for it to gain 1 to be happy, to get to 8. When it gains an electron, it gains a negative charge because electrons are negatively charged. So when it gains that 1, it gets a -1 charge. Okay? So if sodium wants to give away 1 electron and iodine wants to gain 1, it makes the most sense for those two to come together. You can also look at charge alone and go +1 plus -1 is 0. Here's your hint. When you add them together, you only need 1 of each. So when you put them together, NaCl is your balanced formula. Okay? If you wanted to see what that looks like drawn, if drawing helps you with ionic bonding better, we have sodium, and I'm going to switch to a marker. We have sodium, which, like we said, has 1 valence electron. And then we have chlorine, which we talked about, has 7 valence, chlorine, not chlorine, iodine. Get rid of this. Let's just do it over here. So iodine, which is down there, has 7 valence electrons. So it has 1, 2, 3, 4, 5, 6, 7. Notice it has a free space right here that it wants to gain 1. So all that happens is that sodium, like we said, wants to be happy and wants to get rid of this. So it takes it, and if it comes and meets iodine, iodine wants it. Sodium wants to give it away, so it's a perfect bargain, and sodium gives that over to iodine. And so this is how, and notice we only need one of each for us to do that, or like for iodine to be happy and sodium to be happy. If we only need one of each, then we just have to write down NaI. So, silly me with my silly formula over here. You can just get rid of the C, and it is an I here, so it's NaI. My mistake. It's the same ratio for chlorine, though. So that's why I kind of messed up, because you'll see iodine and chlorine are in the same row. So you still only need one of each to be happy. So sorry about that. Your balance formula is NaI. I'll be sure to change that on my actual, what do we call it, worksheet. So, all right. Next one, let's look at calcium and sulfur. So calcium, it says, has 2 valence electrons. If we look at that, calcium is down here. Does indeed have 2 valence electrons. So since it's easier for it to give away 2, it will have a +2 charge. Our other one, sulfur, is all the way over here, has 6 valence electrons. It's easiest for it to gain 2 electrons, so it'll have a -2 charge. So 2 valence for calcium, 6 for sulfur. Calcium will have a +2 charge, sulfur will have a -2 charge. So, like I talked about, calcium wants to give away 2, sulfur wants to take 2. So if you look just at your charges, +2 plus -2 equals 0. So we need only one of each of these to be happy. And so CAS is going to be your equation, your formula, okay? So if we do that on here, got calcium, we got sulfur. Calcium has 2. And sulfur, we said, had 6. Notice sulfur, again, has these 2 open spots down here. Calcium wants to give these 2 up. So it says sure and gives it to sulfur, and they're perfectly happy, both of them like this. And so your equation is simply CAS. Okay? So that was this one. Let's take a look at another one here. Let's look at magnesium and fluorine. So magnesium, if we look for it here, it's over here. Magnesium has how many valence electrons? Hopefully you're able to see that it has 2. And it has a charge of +2. Okay? Which means it's like calcium. So it wants to give away 2. Then if we look at our second one, fluorine. Fluorine is over here. Fluorine has 7 valence electrons. And it has so it's easiest for it to gain 1 electron, so it has a -1 charge. And which means it wants to take 1 electron only. Okay? Now if we zoom in and look at our charges, +2 plus -1 does not equal 0. Okay? Right? Does not equal 0. If anything, that equals 1. Okay? Which means we need another +1 to go somewhere. Okay? Since we have more positives, it's prudent for us to get more negatives in order to balance out. Okay? So in order to do that, if you needed to balance out and get rid of more positives, you add more negatives. So if you added another fluorine, then you would, so for instance, if you added another thing that will take a -1, okay, so if you add 2 things, that would be -1. This turns into -2 plus 2, which equals 0. So that means when you do this math here, that means you need 2 fluorines. Okay? That's how you do it mathematically. To do it this way, the drawing, we have magnesium, which has 2. Fluorine, which has 7, and it wants 1. Magnesium's fine with giving 1 up, but it's still not happy. So in order for it to be happy, we need to get rid of this one. And the only thing we can deal with, the elements we can deal with, are magnesium or fluorine. Like I said, if we need something to take it, we gotta have another fluorine. So if you have another fluorine, who has another open space, magnesium just donates it right on over here. So in order for it to be for everything to be happy for both magnesium and whatever amount of fluorine we have, then you just count up your elements in each, and then you write down your equation, your formula, which is Mg. We have only one of those. And then we have fluorine, and we have 2 of those. And so that is your balanced formula right there, is MgF2. Okay. Let's try doing one that involves a polyatomic. So let's come down here to NH4 plus N. Now you see this right here, this NH4. How do I know that's a polyatomic? Well, polyatomic ions, poly means many, so meaning there's more than one. So you can see here that we have 1, 2 elements in it, which means we have more than just one. We know that because they're capital letters to know that there's more than one element. So we know that this here is not found on the periodic table because it's a combination of nitrogen and hydrogen already bonding together. And when it does that, it gains a charge. That's why it's called an ion. So if we turn to the back here to my polyatomic ion chart, and we look for a polyatomic ion NH4, we see it right here at the top. NH4 is called ammonium. And then we can look on here and we go valence electrons. You can actually, since we don't know the exact number of valence electrons, unless you look here at your oxidation number. So NH4, according to its oxidation number of +1, and I have down here, remember, oxidation number just means your charge. If it's a +1, we can compare it to another thing that has a charge of +1, which is things like lithium, sodium, potassium, which means that it probably has 1 open valence electron. Okay? The element charge on NH4 is the same as the oxidation number, which is 1 + 1, which means that NH4, or ammonium, wants to give away 1 electron. Okay? We have an N here, which is just plain nitrogen. So we have ammonium that wants to bind with nitrogen. Okay? So nitrogen, if we look it up, it has 5 valence electrons. And it has a charge of -3. So in order for it to be happy, that means that N takes 3. Okay. So this is an interesting predicament because, again, if we look at our charges, we can see that +1 plus -3 mathematically is not 0. In order to balance that out, let's get that. So NH4 has 1, and N has -3. +1 plus -3 is -2. We need more positives to get rid of this negative. So overall, we need to add more of these. So if you added another one, that's another +1. That's, now it's +2 plus -3. That's still not 0. So if you added another one, that's +3 against -3, which is 0. So I'm just doing the charge kind of thing, what I did here, kind of visually a little bit, to see that we need 3 NH4s and 1 nitrogen to get a 0 charge and to be balanced. So your charge balance, to get a balance formula, you need NH4. Now, if we put a 3 down here, that says 43. That means that there's 1 of these and 43 of those. This is not how you write this. instead, in order to write NH4 and show there be 3 of them, all you got to do is take your NH4 and you got to put parentheses around it to show it that this is a single entity. And then if you add a 3 here, now this means that we have 3 of these. Okay? And then you add your N after it. Okay? If you were going to do this visually, we do it the same way as what we did over here. You just have to draw out that this has 1 free electron, and then your nitrogen has 5. Notice it has 3 open slots in order to be happy. NH4 is happy to give up 1 of them. But in order for nitrogen to be happy, we need 3 more. Or, sorry, 2 more of these for a total of 3 NH4. So, in any case, whether you do it adding with your charges or visually like this with a drawing, you're still going to get to the same conclusion that we need 3 NH4s and 1 nitrogen to get your balanced formula. So that's what we'll write down here is NH4 3N. Okay. All right. I think we'll do one more on here, and I think I will do another polyatomic ion. Okay. And so that one is going to be, let's do this one. Okay. So we have Na, which we've already established is sodium. So we can actually look up here and fill in everything for Na. Okay. Then we have Cn here. Cn. They're both capitals, so this tells me that there are 2 separate elements, which is more than 1. So this is a polyatomic ion, this one right here. So flip to the back and look for Cn in our chemical symbol here. You look down, 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 down. Now, oh, right here. Cn is cyanide. So when we take the word, we look at cyanide, we see that it has a -1 oxidation number or a -1 charge. Okay, so Cn says it has a -1 charge. So in order for it to be happy, it needs to take 1 electron. What other elements have we seen or looked at so far that is similar to cyanide? Well, if we look up here, we did one with fluorine. Fluorine takes 1, and so fluorine has a valence electron number of 7. So overall, this has 7 valence electrons. Okay. If we look at that, we can kind of compare it and look at our charges, seeing that it's +1 and -1 already. So +1 plus -1. When you add those 2 together, you already get 0. So all we got to do is put them together because we don't need more than 1 of each. So All we do is put down NaCN. And that's it. That's our balanced formula for that one. So notice it's not always going to be complicated and have to be written like this with polyatomics, because if you only have one of them, you don't need to put in parentheses. If you have more than one, you do. Okay? So I'm going to stop there with ionic formulas. So the rest of these, give them a try. Don't forget to look at your polyatomics. Okay? Beware of those. Okay? All right. Then we are going to move on to part 4 with covalent bonding. Okay. In this part, use your periodic table to fill in the table information and then use that information to make a balanced covalent formula or covalent compound. I've done the first 3 here for you to help you see what I'm looking for. Remember, for these, you might need to add more of a certain element or even more of both elements in order to make them happy. Okay? If it helps you, draw Lewis dot diagrams on a scratch piece of paper, and that scratch paper you wouldn't need to hand in to me. It's just something like what I was doing here that helps you out. Okay? All right. I give you another reminder here with what you can do on a Google Doc, and I'll show you that at the end. Okay. Up here, if we look at this example that I did for you, it says, it kind of goes through the same kind of thing that we did on the ionic table. We got valence electrons in your first element and your second element, and then if it, like, how many will it want to share or like be able to have access to in order to be stable. And when we talk about stable, we should be talking about getting to that magic number of 8. Or in the case of hydrogen, 2. Because hydrogen, remember, is Mr. Special, who's up here in this corner. And so him and the hydrogen and helium want to get to 2, which is their highest energy level. But yeah, hydrogen and helium want to have 2. Everybody else wants to have 8 valence electrons. Okay. So if we look up here, oxygen this is the simple looking at your periodic table. Valence electrons for oxygen is 6. Iodine, 7. So in order to get to 8, which is right here at the end, oxygen wants to share 1, 2 electrons, whereas iodine only wants to share 1 because it only takes 1 step over to get to 8. So it will only want to share 1. So if this one will only share 1 time, an O will do twice. We need to have 2 of element 2 or 2 of iodine for them both to be stable and happy. Okay, so what do I mean by that, or like how can you see that? So like I said, you can always do Lewis dot diagrams to help you out with these. So I have oxygen and I have iodine. Iodine, we talked about, has 7 valence electrons, so you draw 7. Oxygen has 6, so you draw 6 of them. And notice, like I said, oxygen will want to share 2 pairs because it has 2 empty spots, 1 here and 1 here. Iodine only has 1 empty spot. So in order for iodine to be happy, it's totally fine with sharing one of its electrons with oxygen. So it has access to 1, 2, 3, 4, 5, 6, 7, 8. But oxygen here only has access to, just like we talked about with iodine, 1, 2, 3, 4, 5, 6, 7. It wants to have access to 8. And so in order for it to be happy, iodine here won't share another one. But if we have to work with just these two elements, we don't need another oxygen. We need another iodine. So if we added another iodine with 7 of its electrons, and it has this free one here with an empty slot next to it, if iodine shares with this oxygen here, this oxygen electron, now iodine, just like this one, has access to all 8. And this oxygen now has access to 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it's happy. So just like before, you just count up what you have, which is oxygen, iodine, and there's 2 iodines. So that is what goes up here. Okay. Lewis dot structures with these covalent ones can really help. With the carbon and hydrogen one, carbon carbon has 4 valence electrons. So if you draw that, and then hydrogen has 1 valence electron. Like we talked about before, notice carbon has 4. It's halfway in between 0 and 8. So it's going to more rather gain or share 4. So carbon wants to share each of these electrons. Hydrogen wants to get to 2. And so it wants to share with each of its electrons. So kind of works out perfectly that each of your hydrogens, or like 1 hydrogen, will share. So you need to add more hydrogens in order for it to be happy. CH4 is your balanced formula. And then lastly, I have nitrogen. Nitrogen, which is here, has 5 valence electrons. Doesn't really matter which one is which colors. Okay. Notice each nitrogen has a free electron here. And it works out pretty great because each of these electrons here will want to share, and we get a triple bond. So when we put those two together, we get N2. Okay, all right. Let's do one of these since these are pretty easy. Let's do HCl. So HCl is hydrogen. Let's here we have hydrogen, which has, like we talked about, one valence electron, and Cl, got HCl. Okay, we'll notice we have one lone electron there and one lone electron on hydrogen. Chlorine wants to get to 8, hydrogen wants to get to 2. They're both missing one hydrogen. Chlorine, they share. Hydrogen now has 2. Chlorine has 8. So your equation is simply going to be HCl. So a valence H has 1, chlorine has 7, hydrogen will share 1, chlorine will share 1. So when you put them together, you get HCl as your balanced formula. Okay, so not bad overall. Covalent bonding, like we talked about, I also forgot to put this down, but is all about sharing. Okay, so not bad overall. Remember, when you're drawing these, if you need to keep adding one on, add until they're both happy. If you need to add more of the middle, that's perfectly fine. Just, figure out how you can share or share the electrons that are present until you have everybody either shared or have all of your singles paired up. Okay. Then there's a couple challenge ones over here. These ones I don't expect you to do, but if you do them, make a balanced formula over here when you add these elements together. So these ones are optional, like I said. And if you do end up getting the correct balance formulas here, I will give you 1 extra credit for each of the correct ones. Okay? So, now that we got that out of the way, I did want to just double back and show you how you can do that really quick trick on Google Docs in order for you to write your correct looking formulas online when you do your online assignments, if you don't want to write them out and if you just want to do them on the computer. So I'm going to switch over to here. All right, so over here, we had one of our equations here. It was MgF2. So if you type in here MgF2, you'll notice that your 2 is big. What you can do is you can make this 2 small 2 different ways. Okay, the first way, I believe you can format this, go to text, and you see the word subscript. That's what those little numbers are called, subscripts. You'll also notice it has a shortcut right here next to it. You can either just click this as it is, and when it's highlighted, it will turn it into a small little 2. Okay. let's say you didn't want to have to go in and do all the click work. You can highlight it and press the control comma, like hold down control and press the comma. When it's highlighted, you can actually turn it from a big number to a subscript or back. So that's really nice. And you can also change it into the subscript right away when you're writing it. Okay. But yeah, that's how you do that. When you're doing these ones down here, remember this one was NH4. So remember to make the parentheses normal sized before you put down your 3. And then N. So that's how it should look. I'm not quite sure how you do this on mobile. Once I figure that out, I will post a video of how you do that on mobile. But I think it's just as easy as going to the format and finding the subscript button. So, but yeah, that's an easy way for you to write out your formulas on the computer to make it easier on yourself and make it easier to read for both you and for me. Okay. Otherwise, like I have up here, if it's too hard for you to do that, you can just simply take this, copy it, paste it, and then all you have to do is replace these numbers and letters here. So you'll notice E1. So if we remember our NaCN, it was just Na. And, you know, if you did have a number, you could just like go over here, highlight it, and then make it a number. Okay, otherwise you could just erase it if you need to. En. And I didn't have, but if I did, I could just erase it and make it a 3 or a 5 or something. Okay, so it makes it a little bit easier for you to block out your whole assignment for you. Okay, but yeah, that's the assignment. Hopefully that helps you out a little bit. Let me know if you have questions. Sorry this was a long video, but I thought I would, you know, go through it like I would a normal class. So, thankfully, YouTube, you can, you know, increase the speed of things if I'm talking too slow or whatnot. So, if you have questions, let me know. I have tried and be on Zoom tomorrow. Otherwise, Discord, you can always private message me, or if I'm in my Discord chat like this, that means I'm there and I'm here to talk directly to, and you can just come in and talk to me, okay? So, yeah. Hopefully this helps you out, like with the practice and everything. Other than that, take it easy. Good luck. And let me know if you need any help. I'll talk to you guys later, and have a good one. Bye.